Hello and welcome to my video 8.2 Properties of Chords. So first of all, like our latest couple videos, assume that the purple smiley face is the center. And we're going to look here at my drawing, and it's not perfect, but you're going to get a sense of this one single rule that we're going to use for this entire topic. And this is the rule. If you look at my drawing, it may be obvious, may not be, but it may be obvious that that's a right angle and that this is a right angle. Hopefully it is. If not, then just believe me. You can try it yourself, but if you do a chord, this is half the chord, this is half the chord up until this point, and you draw a line from the halfway point of your chord to the center line, or to the center dot, then you're going to be making a 90 degree there. That's the rule. Okay? And that's really the only new rule in chords, but I'll show you a couple example questions as well. Okay, so here that helps us because we know x is 90 degrees. Okay? Because it is the right angle. It also helps us because we know this inside here is 90 degrees. And so y is equal to 180 minus 90 minus 30 because of that entire triangle having to add up to 180. So that means y is equal to 50 degrees. All right, so we were able to make the judgment call that that is indeed 90 because of these lines here that hopefully help us remember that those little single lines mean that those two sides are equal. Okay, let's look down here. This one doesn't have that because we have the 90 instead. So it tells us here that this is 90, which means that this is also 90. Which means that these have to be the same. So now we're going to draw those lines in. So if those are the same, currently it says 6 centimeters, so let's half that, 3 centimeters here and 3 centimeters here. Okay, good. Now it says find the radius of the circle. Well, the radius would be from the center point, from my purple smiley face, to the edge. And what's helpful is if we go to an edge we already know about. Right? So now we have 4. Basically, I'm going to draw this right angle triangle out again. But hopefully you can see that we have 4 centimeters here, which was in black. Maybe I'll do it in black. 4 centimeters. And in blue we had 3 centimeters. And now we're looking for the last side, which is a hypotenuse. So that means we have to use a squared plus b squared equals c squared. Because these are all side lengths, not angles, we must use Pythagoras. So here we've got this so far, and let's square root both sides. So now we square root a squared plus b squared equals c. And now if we plug our answers in, square root of 4 squared plus 3 squared equals c, which would be the square root of 16 plus 9 equals c, and square root of 25 equals c, and so 5 equals c. Now this is one of our perfect ratios, and it's really helpful to just remember this because it's a really useful triangle. So it's a perfect right angle triangle. So 5, 4, 3. I've said it before, say it again. 5, 4, 3 is a very special set of numbers. Okay. Last question. What is the closest distance to the chord? Oh, from the center. I should have said that. To the chord here from the center if the chord is 8 centimeters long and the radius is 5 centimeters. Okay, So we have the radius here, and I'm just going to go back to our last question. We noticed that we were able to do a radius in a different place. So just like we did there, I'm going to do it here. So radius, but I'm going to do my radius from here to here. And hopefully you can see that we're just bringing this one down to here. We're just swinging the bar over. So the distance is the same, 5 centimeters. And we're going to use our rule that if we go from here to our halfway point, so we're judging it to be the halfway point, then we're given a 90-degree angle. So it's going to be 4 centimeters on one side, 4 centimeters on the other side. Now we have a right angle triangle, which if you need to, I'm drawing it outside now, which is 5 centimeters here, 4 centimeters here, and we're looking for this side. Alright, so a squared plus b squared equals c squared. Because it is side lengths, not angles, we have to use this. And we've got a squared still, but we've got 4 squared equals 5 squared. Then we have to move the 4 over, so minus 4 squared, minus 4 squared. Cancels there, so now we're left with a squared equals 5 squared minus 4 squared. Then a equals the square root of 5 squared minus 4 squared. I'm writing it out very detailed so you can follow along, but you don't really have to write it quite so detailed. Square root of 25 minus 16. And look at that, it's our perfect ratio again. Because we have square root of 9, a is 3. So maybe you would have seen that perfect ratio right at the beginning, 3, 4, 5. And that's our answer. So really, this is just like our tangent topic, but the only difference is now that we have chords and that we have to know that it's equal on both sides. So like that, equal on both sides, and that means that we have 90 here. That's the only new thing in this topic. Good luck, and I hope you do well on chords.